So, let's take a look at a circuit with a capacitor. This is our capacitor here, and this is our battery, positive, negative. And let's say we know the capacitance, which is 5 microfarad. Let's say we know voltage, that's 25 volts. And, well, what's the energy going to be stored in this capacitor? Well, we know the formula for this is equal to 1/2 times the charge times the voltage square, sorry. And we also know that the charge here, you can write that as the capacitance times the voltage. And yeah, you can see why I wanted to write the square here, because we can substitute this into here and we will get a new formula for the energy of the capacitor, which is 1/2 CV squared. Yeah. So we can substitute all of these values in our equation here, and we will get an energy of 1.56 times 10 to the negative 3 joules. And what we can also do is we can substitute the values that we have given here into this equation, and we will get a charge of 1.25 times 10 to the negative 4 Coulomb. And, well, what would happen now if we would replace this battery with another capacitor? Let's draw this. So we have our first capacitor here, and this is our second capacitor, C1 and C2. And let's say we also know the capacitance of this second capacitor, which is 4 microfarad. Well, what's the new voltage going to be? Because see, the charge is going to stay the same here. Like, no electrons are added to this whole thing, so the charge is the same. But they obviously going to redistribute here, and some of them are going to go into the second capacitor, and that will change the voltage, and we want to know the voltage. Well, we can use again this formula, because the charge is going to stay the same, so Q is then equal to, well, we have two capacitors now, so capacitor 1 times the new voltage plus the second capacitor times the new voltage. Yeah, that's going to be equal to the charge, and we can also write this simply as Vn times C1 plus C2. Do some fancy algebra, and you can see we'll end up with a simple equation where we can now substitute all the values on this one that we also calculated in, and then we will end up with a new voltage of 13.89 volts.